Hi, let's look at this question on applied differentiation. We are given that y equals to hx squared minus x plus k at a particular point p minus 1 minus 10 has a gradient of minus 5. Find the values of h and k. Now, what do we know about differentiation? When we find the differentiation equation for a curve, we are actually finding an equation that represents the tangent at every point of the x value. So, given that y is equals to hx squared minus x plus k, we can say that the differentiation of this, which is dy dx, is equals to 2hx minus 1. The gradient at a particular point is actually the tangent line, the gradient of the tangent line at that particular point. So at this point here, minus 1, minus 10, what we're interested in is the x value over here. So when x equals to minus 1, we can say that the gradient dy dx is going to be equals to minus 5. So with that, we can go ahead to substitute the values inside here. So minus 5 is equals to 2h minus 1 minus 1. Solving for h, you will get that h is equals to 2. Alright, now the next thing we know is that this point minus 1 minus 10 is actually on the curve. So if I substitute this pair inside the equation, so what I'll get is minus 10 equals to h, which is 2, x is minus 1 square, minus 1 plus k. And with this, you can solve for k, and you get that k is equals to minus 13. Alright, so the final equation for y is equals to 2x squared minus x minus 13. So that is your answer for part A. Now, the next part, the equation of the normal to the curve at P. So what is the normal? The normal is the line that is perpendicular to the tangent line, or any other line. So in this case, to find the normal, what we know is when we have two lines that form a 90-degree angle, the multiplication of the two gradients is equals to minus 1. So the rule is m1 multiplied by m2 is equals to minus 1. So the gradient of the current tangent line is given as a minus 5. So minus 5 times m2 is equals to minus 1, which means m2 is equals to 1 over 5. To find the equation of the straight line, we can use the general solver, which is y minus y1 is equals to m x minus x1. So I can say y minus the point is minus 1 and minus 10, so it's y minus 10 equals to m, which is 1 over 5, x minus 1. So solving for this, you will get the final expression as 5y equals to x minus 49. So that is the equation of the normal to the point at P. Alright, so I hope that this question has given you a good idea how to approach such questions of applied differentiation. Alright, thank you for watching, and I look forward to sharing more such videos with all of you. Thank you. Bye.